we're turning our attention to describing the data within our data set, or the variables within our data set. And as we mentioned in chapter 1, one of the big things to bear in mind is what type of variable do we have in front of us, because the type of variable is going to dictate what tools or different visualizations are there for us to use. So we'll start here with describing qualitative variables. And largely the simplest, but oftentimes the most effective way to describe a variable is to simply report the numbers and count up the total numbers of certain classes within that variable. So for instance, if we wanted to learn, or if we had a bunch of data in our class here, and we want to describe, we had the variable hair color, we would want a summary of, okay, there's 12 students with brown hair and 6 with black and 4 with green and 2 with gray. I don't know what the numbers are, but we would want that summarized there instead of just seeing the list of each individual student's hair color. It's much more helpful to have it summarized by the total counts. And so how do we do that? Or what's that called? Well, that's simply a frequency table. Okay, so a frequency table is this is not working, but a frequency table is, let's just jump over to PowerPoint because this Blackboard is not working. So a frequency table, you can see down here. So in this example, the location and number of cars, you have the locations, and I think this is their the sales locations, and we have, so these are probably the 4 towns, and the number of cars. Okay, so we'd have a big list of all the cars sold, and it would have included in there the location that they were sold, and it's very helpful to have that summarized in a frequency table. So a frequency table is for qualitative variables, and we'll have something similar for quantitative variables, but a frequency table is pretty straightforward. The classes are already there for us. Okay, we didn't have to do anything to come up with Kane and Olin and Sheffield and Tionesta other than learn how to pronounce them. And so all we need to do is simply find out. So we'd have a variable with a big list of everything here, and there'd be 180 different observations, and we'd need to figure out, okay, there are these 4 classes, but once we have that, we simply count up the number of cars in each class. And so we'll pop back to this in just a second. I think this is back working. So a frequency table, let's just build one quickly. So for instance, another example, a data example, we've been seeing this credit card data, and I've just pulled up a couple of variables here. So we have the account number again, and then there was a variable for state. So what state is this person presumably living in? And we have a big list of data here, and so we would need to figure out which ones are there. Okay, so and so that's there's no Oklahoma in this list, so we don't need to put a label for Oklahoma. But once we have that, we would have the state. Okay, and I think it was Minnesota, Wisconsin, Iowa, and North Dakota. Okay, and then we would want the kind of the number of customers or something. Okay, and that's where we would then need to count up all of these, however many times Minnesota showed up. Okay, and so maybe I'll just make this up, 11, 7, 6, and 12. Okay, and so then we would have that this is a frequency table. Okay, and I'm just going to put a total line down here just for, and sometimes you'll see it without, but oftentimes you'll see a total listed, and it's usually good practice. to do that. And I think this total is 36. So there are 36 observations, which I don't think is actually true in the data set. I made these numbers up. So we'll work with that actual data and do it for real. But if this was the correct count, we would see the total as 36, and it's a good practice once you've done it to actually check that total against what you're expecting the total to be. Now, that brings up an interesting point, or an important point, is that we need the total within our frequency table to match the total number of observations. Okay, and so actually, if we jump back, there's actually only 30 observations here. So this would not be a viable frequency table. And the reason for that in this case is because I just made up the numbers. But if you ever come across the case where your frequency table totals to a number that's larger or smaller than your number of observations, you'll need to dig into that more fully because there's an issue happening. And we'll talk more about what those... There's potential that you could have fewer if you had some missing data, but we'll talk about that down the road. Okay, so in reality, maybe this is, I'm going to fudge the data, don't actually do that, but let's say it was more this route. Okay, so we have 30 observations and we have 30 here. Now, one way we'll talk about that is that we want our classes to be two things. We want them to be mutually exclusive and collectively exhaustive. Okay, mutually exclusive meaning that each data point, it just fits in one class. So for instance, in our example, we don't have a customer that fits in both Minnesota and Wisconsin. Okay, and obviously there may be a customer that travels between the two, or works and lives in one or the other. And so we want to be certain about what our variable talks about, and maybe this is home residence of the customer, and so that customer needs to fit into only one bin or one class. And then the second one, collectively exhaustive, means there's a class for each value. So we had four states here. If we had a person that did live in Oklahoma, and it was listed as Oklahoma in the data set, we would need to make a class for Oklahoma. We can't have that person not find a class. And so if those both are true, if they're mutually exclusive and collectively exhaustive, then it should it'll always work out that your total is the expected one for observations. So that's an important thing to keep in mind, and make sure that when you're designing your frequency table, you're not leaving someone out, and you're also being specific enough that they fit into just one class. And then lastly, the last little thing that I'll mention is that frequency tables go hand in hand with what's called relative frequency tables. Okay, and so I'm just going to add in a little relative frequency. Okay, and the relative frequency is just the percentage, or turning it into a percentage, or a relative calculation. So we have 30 customers here, and so you can tell me that 11 of them are in Minnesota, but I might also I might want you to present that in a way that just does the percentage calculation for me. So it turns out that is 36 or 0.366. So or 36.6% of our customers are in Minnesota, and we can do that for each of them here. This is 0.233, and this is 0.2, right? And then the last one is 0.2. And again, you can double check that, and it, bearing a rounding issue here, right? This is going to be 0.999 the way I've written it. If you can double check, but of course if I make those repeating like they are, then we would get 1.000. So that's the relative frequency, and just to remind you, just to be clear, this is found by 11 divided by 30, 7 divided by 30, 6 divided by 30, and 6 divided by 30. Okay, and that's all it takes to turn a frequency table into a relative frequency table. And sometimes you'll see just a frequency table, sometimes you'll see just a relative frequency table, and sometimes you'll see them both presented together. And that's a decision for kind of how you're trying to express your data or what you think works best. But that's how we make a frequency table and a relative frequency table. So again, this is for qualitative variables. We'll have something very similar for quantitative. And then the other thing to note is that these can be quickly turned into bar charts and pie charts. So I'll be back with videos on both of those kind of concepts shortly.